Hi. So, can everybody hear me? Not sure always because it doesn't have an echo or something, so maybe I will let the music for now. Don't know if you can hear it. Okay, so I think we can start now. I see there is a few people tuning in, which is great. As always, it will be recorded, so anyway, you can watch it afterwards on YouTube if you don't have the time or don't want to listen till the end. It's not a big deal. So today subject is noise generation. So I know a lot of you are maybe afraid of it because it's actually one of the hardest parts in Minecraft, I think. Well, not the hardest part, but like in terms of algorithm and how it works, actually there is quite a background in math and how to make actually the noise. So it's quite interesting to learn about it, and also it's one of the few parts in the generation code which is actually really slow, and you can't do much about it except changing the noise, but we'll see about it later. So yeah, so today there is a few things that are planned. So the first thing which is planned is of course explaining what is actually the noise. So what are noise and what are the different type of noise in Minecraft. Then we will see the noise implementation in Minecraft, and we will see that it's actually quite different from the regular implementation. And then we will see some specific stuff about the noise and actually how it evolved in different version and so. I'm afraid don't see anyone typing. Is it normal? No one is typing, so I'm always not sure if I'm talking or not, because yeah, no echo. Okay, so yeah, I can hear it, so it's great. Okay, so I'm guessing we can start. Maybe not everybody is already in, but yeah, I mean, we can't wait forever for everyone because else, yeah, we'll not start. And yeah, of course, I try to keep them short, so it's about 1 hour each stream, so it's not a big one. Actually, I'm gonna. I already put in the description some link to some of the stuff I will talk about, if you want to check them out later on also. It's actually the episode 2 of Minecraft primer introduction of world generation. And actually I never published, well, I published the script, but I never published the video, so I actually have it here, like here I have the video and so on, but I never publish it to YouTube. Maybe I will do it afterwards. Anyway, so today we are looking about noise, and first thing you need to know about noise is that actually quite easy to make some noise. You can actually make some noise just by using a random generator, so Java random is all good. And you can just pick at some point a random value between 0 and 1, for example. And if it's above 0, just choose a boolean, it's easier. Boolean, so true or false. If it's true, then it's white, and if it's false, it's black. And then you have a random map. And you get some noise which is like what you can see on the TV or on the old TV, the static noise. So that's what we call white noise or background noise. It's something that it's quite common, and if you look at it in 3D, you will see, well, it will look some kind of like that. So it's quite random. It doesn't have like a general shape, and it have no continuity in it. And it's quite interesting because actually, if you listen it, so maybe I hope it will not be too much. Noise, actually you can make it in different form, and you can actually make it in audio also too. So maybe first in the place. Nice. Maybe it goes to YouTube, I don't know. Oh, anyway, you can hear it, you listen to white noise, and yeah. And so noise, basically just choosing a random value. That's the easiest way to make some noise. But actually what we are looking when we are making a game such as Minecraft is some kind of coherent noise, which means that for a given position, the position relative to it, so next to it, will have the value that are closest to the position. So if I look here I have a dark spot, so it's quite high in the spectrogram. Again, if I get my spectrogram, black, well, depends. It can be low or high. Let's say, yeah, it's low. So black is low, and then it goes gray next to it, and white. So there is a continuity in the noise. So if you cut here, you actually have some kind of continuity along some line. And the Perlin noise actually is great for that, because it can do a continuity in 2D, 3D, can do it in 4D, in 5D, in actually any dimension you want. It's just more complex to do, but it can be done in any dimension. And Perlin noise was actually made by this guy. So this is Ken Perlin, and it was the first time that actually the procedural noise was made, because basically the noise before were just the random noise, the white noise we saw earlier, or were some noise that were handmade or using some other source, and it wasn't great. So this guy had the idea to make a new noise called Perlin noise. And why he wanted to make this noise is actually quite fun. It was for Tron. I'm sure you all know the game, the film Tron. And to make this texture in it a bit random and not bland, they use Perlin noise to make the texture. So all the texture are computer generated and using Perlin noise. So if you look at wiki page, so it's a type of gradient noise developed by Ken Perlin, and it was developed, yeah, like 40 years ago. And yeah, he didn't like that the noise looked like, well, shit, because it wasn't good. So, oh, I see people are tuning in, right? Yeah, we already started. Sorry. So yeah, he wanted some noise that look a bit better. So yeah, he made Perlin noise, and actually with Perlin noise we can do a lot of stuff. And currently Minecraft is running with Perlin noise, so that's great. So yeah, we'll talk about how actually it's done. I would just want to show some stuff. Yeah, so that's Strasbourg's topic. Actually, there is different type of noise you can use. There is Perlin noise, which is maybe the oldest. But actually it's not the greatest in making well a great noise. So there is what we call the volley noise, and there is also the value noise, and also there is simplex and so on. But yeah, each time it improves a lot, and yeah, it's volley, it's not volley, it's an error here. And each time it improves on speed, it improves on quality, because of course you need to be sure that it's coherent and make a great noise, and it's not, well, it looks blurry here, but if you look at value noise, it's a bit sharper. So actually it's better. So yeah, that's all the noise that, well, we'll study today. So it's Perlin noise and simplex noise, and that's a bit of history about the noise. Now I want to just give you a background in how we construct the noise, because I think it's important, and for that, well, I'm greatly inspired from Sebastian Lag, which is actually, well, yeah, he makes great video, and first video is procedural on mass generation, as great introduction about noise, which I will do right now. But if you want to, if you didn't understand what I said, maybe watch it, because actually it's well explained in it, and it will actually give you a lot of insight. Now we will go to how actually a noise is made. So a noise actually is just a sinusoid. Well, it's not exactly a sinusoid, but actually it can be represented as a sinusoid. So yeah, a combination of sinusoid, of course. It's basically just a line which is doing some different amplitude among one axis, and to make it clear, we will label the y-axis amplitude and the x-axis the frequency. So yeah, if we expand, we're expanding the frequency, and if we are going up or down, we are playing on the amplitude. Of course, this image are taken from Sebastian Lag video, but it's just to make it shorter. And to make some noise, we actually generate one of those sinusoid, well, combination of sinusoid. Then we mixed them with different octaves. So it's actually the same sinusoid, but we are actually reducing it a bit. And for that, we are using what we call the lacularity and the persistence. So here there is octave 1, the octave 2, which is actually reduced in the frequency. So we have increased the frequency. So we have this pattern at the beginning, but actually we are getting it 4 times here. 2 times. Yeah. Here we are getting 4 times the pattern, and then we are sampling them and adding them inside one pattern. And to make sure that actually the first octave have greater importance, we are actually defining the persistence, and persistence is actually just making sure that the first octave is better represented compared to the other octave. But that's actually not well explained, I think, so maybe we should look at what it does actually. So if we improve the frequency, as we can see, we are actually seeing more noise of it. So yeah, as you can see, as we go, it's like a zoom. We have a noise map, and we are actually zooming when we are reducing the frequency, and when we are increasing, we are seeing the whole map. Then there is the octaves. So the octaves are basically one at maximum zoom, then one at less zoom, and one at less zoom, and that can be added a lot more. And each time we are making sure to multiply that value of the noise by a certain coefficient, which is what will modulate the amplitude. So it will make sure that actually this one is better represented and this one is less represented. So if we are looking at mixing the different noise, so as you can see here, it's only the first octave. Then as we are increasing, we are moving and we are adding more of the different octaves in it, and we see a lot more relief, and it makes a return which is way sharper and have lots of different parts which are interesting to watch. And so yeah, of course, all of that is based on noise, so it's value between 0 and 1, or -1 to 1, depending of the value. And of course, we can, depending of some function, make sure that we can actually have the mountain which are raised above the sea level, and have the sea level which are in tips. And for that, we just need to actually multiply by an exponential. That's quite easy, and that's usually what we use when we are doing moving with noise. But in Minecraft it's different, so we'll talk about it later. So with noise, actually, you can make the biome. Just a quick recap, because else we'll maybe forget. We saw that actually the biome are done first, then the noise are done afterwards. And the noise actually depend of the biome time. So the biome is actually, let me take a new note. Yeah, it's actually a map, and on your value, different value on each cell, and on each cell you will have a different noise value depending of the biome. So for example, the shattered savanna will have a different noise generator than for example an ocean. Yeah, so the coefficient can be changed depending on the biome. Usually when you are doing a game, you are doing the overlays, so you take a noise, so it can be Perlin noise, Perlin noise, value noise, simplex noise, whatever noise, and then you use it to actually make the biome. Here we are already making the biome with the biome stack we explained yesterday, and also it's called diamond square, the algorithm behind, but yeah. And then when we are done with the biome, we are actually making the noise, so that part we can skip. And then we can go to the last part, which is actually the interesting part. That one, yeah, we don't care. Anyway, you can find the link on the description, so you can tinker with it. It's quite a fun website, I think. So yeah, you can mess a lot with the noise. So here, let's just pretend that it's one biome in Minecraft, so it's all plain. So the noise behaves the same way everywhere. You can move the elevation, you can move some coefficient to make sure that some part of the noise are more represented than others. So yeah, we can also move some octaves. So here it's octave for the biome, so it's different. But yeah, basically in Minecraft, that's what we are modifying. We are using octave for the elevation and making the mountains, the tips, and so on. Anyway, go back to Perlin noise and how actually it's done. So to understand Perlin noise, actually you need a bit of background on maths, I think, and you need actually to understand what is interpolation. So if you don't know what is interpolation, let me get the graph. Let me don't save. Okay, so let's just take a pen. So interpolation is basically you have multiple points on the graph, and you are trying to best fit some kind of so yeah, here. So if we want to best fit this line, actually we want to make sure that it goes through all the points, and for that we can actually make a parabola, and because it's 3 points, so it's the easiest shape, and we can actually make it so. So usually what we do is we take 2 points, then we divide by 2, so we make 1 and 1, and then we join them, and we actually apply a function on the line and make sure that it actually fits the whole shape. So we don't have an inflection point here, we actually have a smoother way. We'll discuss in Octopus about how actually the noise is used in Minecraft later on. maybe I wasn't clear when I explained it, but I think it's better to understand how Perlin noise work beforehand, because then it will be easier to explain the algorithm and how it actually produces some result in Minecraft. So yeah, interpolation is basically just finding the best fit for multiple points in a graph. And that's actually what we are doing here. So when we are making the noise, we actually don't have any point. So what we are doing is we are not making, we could make some point and make the interpolation, but actually we can do better. We can just make for each sample we take, just choose a random slope. And if we do so, we are actually shortcutting the point here. We are actually just making the line. And because we are making the line, then we just need to actually make the interpolation between them and just link them. And as you can see here, the linking is not very hard, it's quite obvious. And to do that, we actually use, well, a formula like so. And we actually can go in higher x, we can go quadratic and go cube and so on. And then we just prolongate them, we find the inflection point, and then we apply the formula. So we put the slope in between, and then when we have the slope, we actually have the Bezier curve, the Bezier slope, yeah, curve. So yeah, Bezier is just a quadratic equation, which is so that's blah blah blah. Is it here? Yeah, you can, well, it looks like that at the end, the equation of the curve. And when we have the curve, actually, you can just well, make it larger, or just take a portion. So if you take that as your first octave, then you have your second octave, which is that, and your third octave, which is that, and then you can just mix them, and you can modulate via the amplitude, like we saw in here, and we can actually make a curve like that. And because of that, we have a final noise, which is here in dot, which is actually quite looking well, random, but it's actually coherent because each point is following the one before, and that's because we have interpolation. Okay, I think I've lost everyone, but it was important to mention that behind Perlin noise, actually, it's interpolation. Okay, so now that we have that out of the table, and that we have saw what it does in 1 dimension, we can actually go in 2 dimension. And for Minecraft, we will go to 3 dimension because it's actually way complex. But yeah, so 2 dimension is actually the same thing. As you saw at the beginning, we choose random slope for the first point, but actually we can do so also in a grid. But for that we need to use vector, because vector have a direction and also, well, can be have an amplitude, but here we are saying it's 1 because it's a unit vector and it's easier. So it has a direction and an orientation. Well, not sure it's exactly orientation, but yeah. So you have actually well, you have two value you get from one vector, which is what you need, because in 2D you need more information than in 1D. And basically, in 2D, what we are sampling is actually inside the cell. So as you can see, a cell has 4 points, and the 4 point will be sampled to get the value in between. So to get that, we actually use, well, an interpolation, but for the 4 vector. So that's done with the dot product. And if you are not, well, if you don't know what is dot product, then yeah, I'm sorry. It's basis, but it's math behind, and you need actually to know what is it to understand really what the noise is doing. But if you don't want, then you just say, yeah, it's the dot product of the 4 vector, and it does some stuff and it gives you 1 point. And to get the dot product of 2 vector, well, you get, it's simple as a formula. And because of that, you actually get that, which is the influence of each vector on the noise, and you get a value for each cell. And if you actually sample it for each subcell you want in the cell, but you could just say that one cell is one point, then you get actually a noise map already. And that's all well, it's interpolation, but it's interpolation with a vector, and vector it's easier to manipulate because it's just dot product. And if we go to 3D, then we actually have for a cell, which is a cube, we have actually 8 vector, and the vector is in 3D, it's not in 2D, so it can actually, it has one more degree of freedom, so it can move a lot more. And in Minecraft actually it's used once, but yeah. So basically, if you want to rotate something, Minecraft, it uses Perlin noise and simplex noise, which we'll see later on. Perlin noise basically is just interpolation between, so interpolation between points, and then when you have a thanks for I get it. I mean, you are not forced to watch the stream, it's recorded, so you can watch it afterwards. I mean, just some experiment I'm trying to do, so to see if actually it can help you to make it clear for people. So Perlin noise, it's just interpolation, and then when we have Perlin noise, then we actually can extrapolate some elevation, and from the elevation we're actually making the mountains. And of course, Perlin noise, we are actually making Perlin noise octaves to make the mountains, boulders, and so on, and little stone and so on. So making a real mountain, so it looks not just one straight mountain and with no decoration. It will look a lot nicer. Perlin noise is not exactly used for randomizing. It's actually a coherent noise, and maybe I didn't put that. It's used to actually give the elevation, and it's coherent noise, so it means that each step there is actually a relation between the next and previous point. Okay, so we have seen a lot of stuff about different we will not see about the optimization. Simplex noise actually is a bit different. If you want to look at the original Perlin noise by Ken Perlin, you can actually find it on his website, the university one. Then I linked a nice code pen. So yeah, Perlin noise use the seed to actually it uses Java random with the seed, so it's 48-bit, and it gives the elevation. But we'll talk about that in the next part. So just want to conclude the part about the noise in general and how it works. So here are some nice stuff you can do with simplex noise and particle, because simplex noise is a lot faster, and we will discuss about it. And if you want really to know a lot about it, about noise, then you should actually read that book, which is a book of shader, and this has a lot of stuff, and it's also in a lot of language, so if you are not a native speaker, well, you can move it. So in French it's a bit easier for me to understand, but yeah, it was used for the front movie, and yeah, it's quite well explained in that book, and also it's linked in the description, so it should be relatively easy to find it. I can put it in the chat, but it's also in the description. I mean, I think it's in the description. I mean, I made Yeah, it's all in the description. I made sure of it. Yeah, so you can find it in the description. But yeah. Anyway, so we have seen how the noise is made. Well, it was actually my first part in the video, which is 10 minutes. It was 5 minutes, and here I'm at 30 minutes. Oof. Yeah, I was not fast. Okay, but actually we are done mostly because we have done a lot of stuff. So we have done the first step, and actually we can do the second step, which is actually the most interesting one. Let me get some water. Which is the noise implementation in Minecraft. And the noise implementation in Minecraft is used for the overworld, of course. It's used also for the end dimension with the simplex noise, and it's also used for the nether dimension with some Perlin noise and let me check it one first. Nether layer. Yeah, it's a double Perlin. It's a mix of two Perlin noise inside, and also various different Perlin noise which are mixed and get together. So let's take a look at how it is defined in the code. So maybe let's take a look at how it was in 1.12 before everything changed, because there is a lot of stuff that were added, notably the 3D noise, even if it's not used. So let's just look at the octave first. So as you can see, you give it a number of octaves, so usually it's 8 in Minecraft. And yeah, it's not very clear here. Maybe in the improve one. Oh, damn it. Yeah, it's not very clear. Let me get something here. Yeah, here. No, that's not clear. Yeah, I think biometal will be the clearer for you. Maybe, well, I hope so. But yeah. So the first thing that is done is actually, well, the Perlin sampler, but that's the Perlin algorithm which I described, which is actually getting the gradient, and it's actually the dot product behind. So if you are looking at what is actually a gradient, it's actually a dot product, and it's using well, a table, which is a simplex table to go faster. But yeah. But what is interesting is how actually it's done, and for that we use what we call the Java random generator. So if you didn't watch the first video, then I recommend to watch part 0, because I explained what is actually a Java random. So Java random is a PRNG. It uses 48 bits to actually have its internal state updated. It's a LCG, so each step it goes, it changes its state and produce an output. So if I get some diagram, it changes state internally, but each time it gives an output here. So we get a value, and each step it changes, and that's possible only for 2 to the power 48 at maximum. Then it goes back to the first state, and because it's deterministic, it goes at the second state, which was already visited. So that's how the Perlin noise is actually seeded. So it uses a Java random object. Then there is actually the X, Y, and Z parameter, which are used later on when we are using the noise to make some modification on, well, X, Y, and Z. But what we are using, and what is different from the Perlin noise algorithm from CanPerlin, is actually we are making a permutation table with a random next int, which are decreasing. So it's 256 to 1. So the last value will actually be 0. Yeah. And yeah, we get a permutation table, and from this permutation table we are actually well, getting some point of it, and making sure, of course, that they are correct according to well, to the rule of the Perlin noise, which are to have some coherent noise among some all the axes. So it's mainly done in 2D in Minecraft, but actually there is a 3D implementation also. So yeah, it's not really clear as you saw it like that. So that's why I did the 30-minute introduction about the noise, because it's not really well, the code is a bit finicky to look at. And then when you have generated one Perlin noise, you actually make it in octaves. So each octave is actually a Perlin noise, and each Perlin noise is actually conditioned by the linearity and the persistent. So as you can see here, well, yeah, it's not really clear again here because it's used some fast stuff which are used to actually improve the speed. But we are actually making sure that we are well, having the octave which are less which are well higher, making a less important noise in the global noise. So we are following exactly that picture, which is to make one octave, a second octave which is larger, but actually have less importance in amplitude, and so on. So that's how we get it. That implementation again is a bit optimized, so it has some stuff which are actually not clear in it, but yeah. Then there is a simplex noise. So the simplex noise is a fast noise, and because it's a fast noise, well, it uses the same stuff to seed itself, which is actually to use the Java random and to make a permutation table. But then again, it uses some other stuff, which is not actually to sample on a cube. So Perlin noise actually is making the dot product of 4 vector, something like that, and it's getting the dot product at each point in the cell. But actually, for the simplex noise, we are using a triangle, and we are actually sampling in triangle, and because there is less vertices, we are actually going faster. It's the fast random, of course, there is link to learn about it. And yeah, simplex noise is used for a lot more stuff because it's actually way faster. So for the biome, for the end dimension, for example, we are actually using a simplex layer for the first layer. So end biome is simplex layer, then there is actually some other layer which are used for getting the height correctly and so on. And never is actually using the Perlin noise as its layer. So it supports 3D, but it's actually way slower. And for the overall, so that's for the biome. For the biome, so biome in end and never are used with noise, and in overall it's actually the biome stack. That's why the never there is only 2 to the power of 48, and for the end also, compared to the world which have 2 to the power of 64. So if we want to recap that, let me get the notepad. Okay. So never is actually using Perlin noise. Thus, it's using yeah, maybe first Minecraft noise are actually initialized with Java random, which is actually really important because that means that their internal state can actually not go above 2 to the power of 48. Then the never is using Perlin noise, so it's quite slow, even if we can actually generate it fast in our current computer, but I mean it's slow compared to other noise. And the end actually is using simplex noise, so it's a bit faster, but there is also some caveats, which are that Mojang is not caching some stuff really fast. So actually it's as equivalent to the never in the implementation of Mojang. Then when we have so that's actually for the biome, because I need to precise that, and the overworld is using the biome stack, which we saw yesterday. Yeah, yesterday, and that's 2 to the power of 64 states. So that's different from the Nether and End. So for a given seed, actually there is a 2 to the power of 16 identical Nether and End. But just well, some stuff you can derive from that information. If you want actually to look at what it matters actually in the world, it's actually how the noise is used to make the mountain and the relief in Minecraft. And that's done thanks to the chunk generator. And the chunk generator basically, so that's Minecraft 1.12, is using 3 Perlin noise, which are the main noise, to generate a 8 map. So 8 map is basically so let me get that. It's basically you have a chunk. So that's a chunk. Again, I'm not good at drawing, but yeah, that's a chunk. And 8 map is basically just getting value for each of the possible coordinate in that chunk. So in the Y, in the X, and the Y-axis, the Z-axis. And for each of them, you will get a value, but of course it's coherent because it's using a Perlin noise behind. So each actually noise will be coherent. So if you have a shape in it, actually it will propagate in every direction. So you will have something that looks like a mountain in behind. And of course there is some condition, so at some point it will convert to air, so because it's too high, and if it's below sea level it will be stone or gravel or dirt or something like that. And that's done in generate height map. So there is what we call the main noise, the min limit and the max limit, which are used to make actually the different to mix again some noise and make sure that they all give some relief and good and how to say it, so some good shape to the terrain. Maybe we could get back to oh, I don't remember exactly it was, I think, that one. No, it's not that one. It's maybe that one. It's that one. So if I go back to my first so it's basically just making sure. So if that's its main Perlin noise, then when you are adding a second Perlin noise and a third Perlin noise and you're mixing them, you are making the relief a bit more better, because you are adding more noise and making sure that they are mixed. How many tutorials will I make? Actually, I don't know. I have something prepared for tomorrow, so tomorrow at least. Maybe, I don't know. It depends if I have some topics to go. Basically, it's not really tutorial. It's just information, general information about stuff that I want to share. Anyway, so yeah, in Minecraft there is actually 3 octaves which are made together in one chunk. So again, in one chunk like that, and then each time the chunk is filled, then there is actually some other stuff which are done, which actually is replacing the block in it. So we have actually a skeleton which is made of stone, air, and maybe water. And then when all of that is done, the air is not changed, of course, but at the limit of the stone, there's actually dirt which is generated. There is also grass at just above. So yeah, there is grass here, there is dirt here, and if it's in the water, here in the water, then there is a gravel which is made just below, and so on. And of course, after there is a population stage, and in the population stage there is the vein which are made, and the vein are dirt vein and so on. Well, that's after all. But the first part is making a skeleton which is using some stone, air, and water, and that's used actually in most of the dimension as the first step in generating, because it's easier to have some skeleton of what the noise look like than actually modifying the block ID accordingly to some rule. So chunk generator end actually is using the same stuff, so is using free noise. Then it's replacing each of the value which are the stone, the air, and so on, with actually the end stone and the different stuff it needs to put in. And that's done for every chunk generation, so each relief is using actually some Perlin noise behind the scene, except for the part where it actually generates the dirt and so on, because that's done with simplex noise. So that's actually how it's done in Minecraft. I know it was not really clear for a lot of people, and when I will listen to it I will say, yeah, it's not clear at all. But maybe we can look actually at Minecraft. So if we go back to Minecraft, go to 1.12, when actually it was possible to modify stuff, because yeah, beforehand it was not really possible to modify stuff. So that's actually the fun part, which I showcase some stuff, and it's actually not me explaining code and so on, because that's boring, I know, for a lot of people. If we go back to what we could do before, which is actually to modify some stuff, world generation customized, could actually go to the next page, and actually change some of the noise setting. We could actually change the scale of the main noise, so among the X, Z, and Y axis, which is what I call the main noise, which is the general shape. Then we can actually change the depth, which will actually increase the depth of the ocean, and also will increase the height of the mountain in some way. The height also increase the height, but yeah, the depth and height are actually they are in the same condition, like they are multiplied together, so they give 1 over the other. There is also the limit you can put, and you can actually depending on the biome put some depth or more scale depending on the biome. So that's what I meant when the biome can influence the noise. It's basically that depending on the biome you can actually scale differently. So let's say, for example, that we scale among the x-axis, the z-axis, and the y-axis. So if we do so and we generate, so that's a random seed, we don't care. We'll see easily what happened. So that's plain, so you don't see a lot of stuff. Actually, you will not see anything because you are scaling accordingly on each dimension, so you will see some floating, but it will not be something that you could actually see because you are actually just deleting the world noise. So you are actually just making it so you see more of the small noise, but yeah, you will not see a large difference between standard generation. If you go at the mountain, you can actually see what I meant by just deleting the noise. So as you can see here, the interval between the different steps is actually way larger, and that's because you don't have as much of the small noise, so you are forced to have some higher step because you are seeing a lot of the small noise which is deleted, so you are seeing less interval. So let's say that before the interval were like so. Now the interval are like so. Yeah, like so. So you're actually seeing less of the noise, which means that actually you are seeing some stuff which look a bit weird. Well, not weird, but different than standard Minecraft generation. And that's basically what we remove, which is well, I think boring because actually it was fun to mess it with around. And yeah, noise generation is actually something that it's really interesting and you can make some pretty stuff with it. It just needs to be tailored so it actually makes some interest in your game, and that's why Minecraft use some specific value. For example, some of you which know the code might know about so that one 60. Is it 9? Did I actually messed it? Oh, darn it. Is it here? Here. Oh yeah, it's that one, for example, which is actually just a value that was chosen because it was great for that noise. Some of the value are specific because it's actually a pi and so on, but those values are just because it was great with that setting compared to other setting, and yeah, it was chosen like so. You can actually, for example, change the depth exponent, so you are changing the exponential curve, for example. Well, it's not exactly the exponential curve, but it's like so. So it's like when we go back, oh, I close it, yeah, you will see easier. So let me get that. So that actually, so yeah, here actually seeing it's a bit higher. Let me find back the mountain. Ah, it's so slow. Why? Maybe because I'm streaming. Yeah, that may be why. Okay. So yeah, you might not see it actually. Yeah, you might see it here. That might be here. You can see it actually. So here you're actually seeing some of the depth effect, which, well, yeah, you don't see really, but like, yeah, it's straight. So one question: was it worth finding pack PNG? Well, it was requested by a lot of people, and finding it just made it so we can focus on some other stuff. I think, well, and plus people were happy to find back that it exists, and so on. I mean, I have no response, written for that. Like, for me, PackPNG was just one other project, and yeah, it was fun to work in. Like, I learned a lot about alpha and beta, but yeah. Anyway, so yeah. Actually, you can mess around with a lot of coefficient and modify a lot of stuff in the biome generation, and that's actually the interesting part about it. I think I cover how it is used in Minecraft. So it is used for the biome and never, but it's also used for the elevation and the relief. So to make the mountain, to make the cliff, to make the plain, because the plain actually have some relief, to make the depth, the trench, let's say the trench, and so on. Like, you can actually make a lot of stuff with noise, and that's basically the main use in Minecraft. So I don't know what I've planned for the left. Oh, it evolved. Oh yeah, because it changed a lot between the version. So yeah, of course, if you want to tinker with it, there is some libraries well, you can just use the copy of Minecraft noise generation, or you can use it in Rust. There is actually a repo called noise errors. So it's on GitHub again, on GitHub and also in crate.io. And yeah, there is Perlin and the simplex noise which are implemented. But now let's open alpha, because yeah, we talk about PackPNG, but we can actually talk about alpha also. And in alpha, actually the noise was quite similar. There was the three main noise, but the coefficients were different. So as you can see, the coefficients were a bit different. Well, there was still this coefficient, but like the Y was changed later on. And there is also the surface and the depth noise, which are used to again modulate the intensity of the three main noise. And then you have when you are, so that's to generate the noise column, which are actually, if I go back to my drawing, this. So that's the noise column, and the noise column then are sampled in the X and the Z plane, and then you actually make the terrain. So for that you are actually interpolating, because you are not actually making all the noise column. So if I want to actually be clear, I need to make a new drawing. Don't save it. So actually, when we are making some noise to generate a chunk, we are actually making it in a 5x5. That's 1, 2, 3, 5. 5x5 grid. Then in the 5x5 grid, we fill it as a noise column, and of course we are not making it till the word height. We are actually making it 17 or 32, depending of if it's Y 128 or Y 2000, no, 256. And then when we have each of this 5x5 column, we are actually sampling by interpolating for each of the cells. So we are taking this cell, this cell, this cell, this cell, and we are actually making a 4x4 out of it. So we are using 4 value to actually make a 4x4, and inside we are actually sampling everything to well, we are interpolating everything, so to make it so they actually look coherent and have some stuff. So that means in well, in alpha and so on, there was some weird artifact because of how it was done, and there was actually some error in how the noise was taken into account. So that made a few stuff weird. But as you can see, it's done here. So basically we are taking the, oh yeah, sorry, yeah, we are taking 8, of course, because we are in 3D. So we are taking 1, 2, 3, 4, and then the 8 below, and we are actually taking 2 by 2 by 2 cube, and we are sampling the middle of the 2 by 2 by 2 cube. Yeah. And yeah, we are taking the 4 noise value. Then we are, for the 4x4 times 8, we are actually making sure that it's correctly interpolating, and we are making the stone skeleton, so we can actually then replace it with different block depending of the position. So we can put sand, gravel, and modify the height a bit, so to height to elevate a bit, so we can add some dirt on, and also some grass on top. So yeah, that's basically how it's done. And in alpha it was really simple. Then actually it didn't change a lot, it was just well, made better because the coefficients were tinkered with, and also they made sure that they actually sample a lot more to be sure that they, well, they get the most of it. But it's also the same stuff. So we have the 8 value here. Then we are actually making the 4 by 8 by 8 because we are actually needing, well, we are sampling a lot more here. And then we are making the same skeleton of endstone. And yeah, I know it's 4 by 8 by 8, so that means that y is 4 and x z is 8. But yeah, basically it didn't change a lot. It's always the same stuff. We are actually making Perlin noise column, then we are sampling the column in a 2 by 2 by 2, and we are making a larger map of it, which actually is made from less data. So we are actually making more data from what we have actually as noise. So that's why there is some weird artifact, but that's not important because as you can see, like, it's a general shape that matters. If it's only in a in a quarter of a chunk, it's okay. Like, if it's a full chunk, then it will not be okay. But like, because it's 1/64th of a chunk, or 1/16th of a chunk, it's okay to have less data to make actually the stuff, because most of it anyway will be either air or just stone. So what's important is the transition in between. So anyway, I think I cover most of the stuff. I know it was actually not, well, maybe a bit long, maybe not well explained for some stuff. So if you have any question, just, well, don't hesitate. I mean, the point is actually to interact. I mean, I have, well, a few questions, but they are not really related to node generation, which is a shame, I think. But yeah, I mean, I didn't warn anybody about it. It's like just random stream, and I know it can be hard because people are not used to it. But yeah, if we are, well, looking at the last project in Minecraft at Home, for example, we are looking for Herobrine, and in Herobrine there is actually some interesting stuff you can use in Alpha 1.0.16 in the noise, because there is actually some error in it. So for instance, there is error in how the depth and surface noise are calculated, because the coefficients are just wrong, so you can use that. Also there is other stuff that are changed, so you can actually use that to attack the noise. But again, the noise generation is quite slow because behind the scene it's using Perlin noise, and Perlin noise is hard to generate because it's not optimized as much as some other stuff. Like I said, Perlin noise is a cube. Well, actually, it can be well, it's a square in 2D or a cube in 3D, and simplex it's just a triangle. And if you are going in 3D, then it's a tetrahedron. So it's actually also easier because there is less vertices, and so less vector to sample. But yeah, simplex has also its limit because it's not as good as the noise as, well, as it can be when it's merged together. So each noise has a different advantage compared to the other, and well, you can search on what is the base noise, and you will find different response depending of the well, what you are looking actually for. So let me put some random word. Yeah, but of course it's comparison, normalization of yeah, I don't find exactly what I want. Too bad. Maybe if I look for Google, because Google knows it. Oh, maybe there is that. Taking time to load. The fuck. Well. Yeah. It's not well. It's not a big. Anyway. I think if I can't link something, it might be supercoder, I think. Let me fetch the link because some of its stuff are quite fun to watch. I think it will be something like that. Let me find the correct repo. No, that's not the one. So yeah, that guy. Basically, yeah, it made a few stuff which are interesting, so you can watch different noise in Minecraft. So simplex terrain, I think that's the one. That's to watch simplex, yeah. So standard simplex noise, so you can have like noise which are actually way amplified. Perlin noise, which is quite bland, which is normal generation in Minecraft. Cubic noise, which is I think it's an open source alternative, which actually gives some interesting patterns, but actually, well, it might look to the main lies like some not random at all. Whirly noise, which usually is called as one of the best noise because it makes well nicer turn, so that's good. Foot idle noise preset, I don't know about it. Yeah, I'm guessing we need to follow that. Okay, it's coming soon. Anyway, yeah. If you want, yeah, to mess with that, I'm guessing it's just a mod. So yeah, it's just a mod, so you can install it and can play with it. I think it's nice to watch what they do, then you can learn about the algorithm, implement them yourself, like in different languages, and then you can just play with it. But Minecraft is using, well, Perl noise for the chunk generation, and simplex noise for the biome in the end, and also some of the latest part of the chunk generation, like the dirt height and so on. But yeah, I think that concludes everything. I think I will put that link in the description because it's quite nice to watch, and I think, yeah. So yeah, okay, and let's add it to the description. So thanks all for tuning in. I think, yeah, it was maybe not clear everything, but I hope a lot of you have well, gotten some of the stuff I said. And yeah, so we saw how noise generated. We saw yesterday that how biome generated, and we saw that well, the day before yesterday, that how structure works and how also Java runtime work. So I think that tomorrow will be about something else, and I have two subjects I want to talk about. The first one might be hard because it's actually a lot of math and linear equation. So it was about latticity, but I think I will put that next week because actually I'll need it to be a lot clearer, and maybe Matthew can help on it. So tomorrow will be about recursion. And recursion, I mean like how Minecraft generation work, or Stronghold generation work, and so on. So that will be a fun subject again. It will be a lot of explanation, but there is a few visualization that could happen, and it's again some part of Minecraft you need to know if you want to do some synth fighting, because it's useful. So yeah, thanks for tuning in, and again, same hour tomorrow for recursion. See ya!